When 3 Atlas first came into view, it was a fleeting object in the night sky, an anomaly that seemed ordinary at first. But on November 9th, everything changed. Astronomers captured the first images of the comet, but they were stunned. A tail stretched millions of kilometers behind the object, a feature far larger than anything previously observed for a comet of its size. The problem was that comets simply don't behave like this. Gas tails typically extend a few thousand kilometers, driven by sublimation of volatile materials in the comet's core. But this tail was enormous, far beyond the expected size for an object as small as 3I Atlas. Calculations showed that for the tail to stretch so far, the object would need to expel vast amounts of gas at a rate far higher than any known comet. What was truly disturbing, however, was that this tail appeared seemingly overnight. Just days before, there had been no sign of any outgassing at all. Then, in an instant, the tail emerged fully formed, stretching millions of kilometers away from the object. This abrupt change was unprecedented in comet behavior. For comets, the production of gas is a gradual process taking months to build up. How could 3I Atlas, which was previously inert, suddenly develop such a massive tail without any precursor activity? This sudden outburst couldn't be explained by typical models of comet behavior. Was there something unique about 3I Atlas? Something about its composition, structure, or trajectory that allowed it to defy the known rules of comet behavior? Or was there something far stranger happening that no one was yet ready to comprehend? The mystery deepened as scientists began to assess the mass of 3I Atlas. Initial calculations showed that the comet was losing an unfathomable amount of mass, about 50 billion tons of material every month. This was a shocking figure considering that the object itself was only believed to weigh approximately 33 billion tons. How could an object lose more mass than it actually weighs? This simple fact contradicted the basic laws of physics, where the mass lost in the tail should never exceed the total mass of the comet itself. This anomaly raised alarm bells among the scientific community. Was this a miscalculation, or was there something fundamentally wrong with the way scientists were measuring the comet? Comparisons were drawn to the infamous Shoemaker-Levy 9 comet, which fragmented in 1992, releasing far more material than expected. It shattered into pieces, each one contributing additional surface area to the outgassing process. But 3 Atlas wasn't breaking apart, or so it seemed. It remained intact, its mass seemingly undiminished by the vast amounts of material it was ejecting into space. So what was happening? Could the measurements be wrong? Perhaps the object wasn't as massive as initially believed. Or was it possible that 3I Atlas was shedding material in a way no one had ever seen before? It was clear that standard cometary physics were failing to explain what was happening, and a new hypothesis was beginning to form. One that might explain both the unexplainable tail and the rapid loss of mass. Given the magnitude of the gas and debris being ejected from 3I Atlas, astronomers expected the object to break apart, scattering fragments across space. Comets have a well-documented history of fragmentation. When an object like 3I Atlas passes too close to the Sun, the intense heat causes the ice and gas inside to sublimate at extreme rates, sometimes resulting in the comet breaking into pieces. However, something peculiar happened. Despite the huge jets of gas and dust that should have caused it to fragment, the object remained remarkably intact. Multiple observatories, including Hubble, observed the comet over the course of several days, searching for signs of fragmentation. They looked for small pieces, debris trails, or any indication that the object was breaking apart. They found nothing. The images captured showed a singular bright nucleus surrounded by a glowing coma, the typical structure of a comet. But what was striking was that this coma didn't show the chaotic behavior expected from an object that was losing more material than it could possibly hold. No fragments, no debris, nothing to indicate that 3I Atlas was breaking apart as the laws of physics would suggest. This raised an even more troubling question. How was the comet able to withstand the intense thermal stress and still remain intact? Could the object be composed of something far more resilient than ordinary cometary material? Or was it possible that the surface we were observing was merely a shell hiding something more bizarre, something capable of resisting the forces of fragmentation? One of the most perplexing features of 3I Atlas was the discovery of a second tail, pointing directly toward the Sun. This tail, known as an anti-tail, was unusual. Most comets have tails that are directed away from the Sun, pushed outward by the solar wind and the outgassing of volatile materials in the comet's nucleus. But 3I Atlas seemed to defy this rule. This anti-tail pointed almost directly toward the Sun, with only a small angular offset. To make things even stranger, this tail was stable. It didn't flutter or behave erratically as one would expect from the highly dynamic forces at play near the Sun. Instead, it seemed perfectly aligned with the solar axis, as if deliberately maintained in that direction. Anti-tails are rare, but they can be produced under certain conditions when the gas particles in a comet's tail are caught in a gravitational or magnetic alignment. However, the consistency of 3I Atlas's anti-tail raised more questions than it answered. Why was it so stable? What could be causing this alignment, and why did it remain unchanged as the comet continued its trajectory through the solar system? Some experts speculated that this might be a natural phenomenon. Others wondered whether the anti-tail's precision could be evidence of some external force, a force that was subtly controlling the comet's path, perhaps through some unknown interaction with the solar wind or the electromagnetic field of the Sun itself. The strange behaviour of 3I Atlas wasn't just in its tail or trajectory. There was something about its composition that didn't add up. Astrophysicists began to speculate that the comet had developed a hardened outer crust due to billions of years of exposure to cosmic radiation. This crust could explain the comet's unusual behaviour. The outer layer of the comet might have been chemically altered by the bombardment of high-energy cosmic rays. This transformation could have turned the comet's surface into a tougher, more resilient material, capable of withstanding the intense heat of its passage through the inner solar system. The surface of the comet might have become a protective shield, preventing it from breaking apart under the stress. Interestingly, this hypothesis found some support in the analysis of 3I Atlas's chemical composition. The James Webb Space Telescope revealed an unusually high concentration of carbon dioxide in the comet's atmosphere, 8 times more than in typical comets. This could be the result of cosmic rays interacting with the comet's surface, converting carbon monoxide into carbon dioxide over billions of years. But even with this crust, the massive jets of gas and dust continued to be expelled from the comet. This was a puzzle. If the surface was hard and sealed, how was material escaping? Was the crust not solid but porous? Or was there something deeper within the comet that was driving the activity? At this point, a disturbing possibility began to emerge. The behaviour of 3I Atlas wasn't just odd, it was deliberate. The comet wasn't just drifting through space, it appeared to be following a carefully calculated trajectory, adjusting its velocity in a rhythmic, predictable way. Scientists at NASA's Jet Propulsion Laboratory noticed subtle changes in the comet's speed and direction. These weren't random fluctuations caused by solar wind or gravitational influences. The adjustments were precise. It was as if the comet was actively navigating. This suggestion was not immediately accepted. Some theorists argued that the changes in velocity could be caused by outgassing, where gas jets from the comet's surface produce small amounts of thrust. However, this explanation didn't quite fit. The changes in velocity were too controlled, too consistent. It was as though the comet was actively making course corrections. Could the comet be under the influence of an unseen force, one that was guiding its path with purpose? Or was it possible that the object had some kind of internal mechanism, a kind of propulsion system, which allowed it to adjust its trajectory as needed? The idea that 3I Atlas might be more than just a natural object was beginning to gain traction. Then, something even stranger happened. As 3 Atlas neared the Moon, astronomers captured images showing a faint pulsating light emanating from the comet. The light would brighten, then fade, in a slow, rhythmic cycle, almost as if the comet was breathing. This phenomenon wasn't just an optical illusion. Independent astronomers, using different instruments and analysis methods, confirmed the pulsations. They appeared to be coming from within the comet, not just reflected sunlight. The pattern was too regular to be random, and the behaviour didn't match any known cometary activity. NASA dismissed the light as a data compression error, a likely cover-up, some speculated. But the idea that this pulsating light was somehow linked to the comet's inner workings raised alarming questions. Could it be that 3I Atlas wasn't just a chunk of rock and ice, but something more complex? Something that had internal processes that humans had never witnessed before? Astronomers continued to monitor the comet as it drew closer to the Moon, hoping to unravel the mystery of the pulsating light. Was it a sign of advanced technology, or just an odd quirk of the comet's physical properties? The answers were elusive, but one thing was certain. Therishi Atlas was no ordinary visitor. Just as the world was beginning to grasp the magnitude of the anomaly, NASA went silent. The live telemetry feeds from observatories around the globe suddenly stopped. No updates, no explanations, no press briefings. The public was left in the dark, with only rumours and speculation to fill the void. Inside NASA, the situation was far more complex. Leaked reports indicated that senior officials were deeply concerned about the implications of 3I Atlas's behaviour. Emergency meetings were held in secrecy, and data was shared with top defence agencies, not the scientific community.